All right. So we're live. So good morning, or I guess good evening, everybody, and welcome to the TST meeting. Today, the primary topic will be a presentation about the Artemis project from our contributors from Europe, and with follow-on discussion. So with that, I'm just going to hand it over to Lefteris then.
Hi everyone, my name is Lefteris Manasakis. I'm working here in the Foundation of Research and Technology in Greece. And we are a group, we are called Inspire Group from the Initials Internet Security, Privacy and Intelligence Research. And our principal investigator, Xenofontas Dimitropoulos, who is also present in the presentation, is also a professor at the University of Crete. This is our team. Together with me is Dimitris Mavromatis, which is the main developer of Artemis, and Vasilis Kotronis. The three of us collaborated in this project. And our group has a diverse research topics that we're interested in. Software-defined networks and network monitoring systems are two of them. That also relate to the Artemis project and the Artemis application that we developed. And I'm gonna give the token, as we say, to Vasilis now, Vasilis Kotronis, who's gonna start with the presentation of Artemis. And we should tell you that you can interrupt us at any moment and ask questions.
Okay, hello everyone. This is Vasilis from the Inspire Group. So the agenda from our side today is first to give you an introductory presentation of Artemis over ONOS. Then Dimitris will proceed with the demo of the application. Then we can discuss some features and some characteristics of the code, and also future directions regarding the collaboration between the two groups in terms of implementation of Artemis. And of course, as Lefteris mentioned, you can ask us questions during the presentation or whenever you want. We will be happy to answer them. So first of all, some motivation. We have observed that the BGP prefix hijacking remains a serious threat also today, with some quite serious incidents. In the meanwhile, we have a multitude of pervasive control plane monitors, like from Ripris or RouteFuse, and frameworks like BGP1 and BGP Stream that provide or plan to provide real-time streaming access to these monitors. And these frameworks fuel approaches such as the original Artemis, which is presented at SICOM 2016. And I will talk more about Artemis in a bit. Furthermore, there are network operating systems such as ONOS that enable automation or full automation of control plane actions. And we consider this as ideal to implement and evaluate Artemis over such a system. Now, the open source tools that we're using is Artemis as an application, ONOS with emphasis on the STNIP project to interface with BGP, GNS3 as the emulation software, actually emulation platform, VirtualBox for virtualizing endpoints, and finally, open source routers and switches based on WAGA, ExaBGP, and OVS. At the end of the presentation, I will also provide some details on each of them. Now, some introductory things. First of all, prefix hijacking is quite an old problem. So NAS can today own a prefix and announce it via BGP to the rest of the world. And the internet will start forwarding traffic towards this AS. Because BGP doesn't have an embedded authentication mechanism, a hijacker, AS, can also say that I own this prefix and I announce it, and some parts of the internet, depending on policies, on shortest path, and so on, will start forwarding traffic towards the hijacker. The hijacker then can black hole the traffic, can intercept it and modify it, and can even forward back to the original ASN, but after having inspected the packets. Of course, the community has known this for decades, and there are mechanisms like RPKI, but their adoption is extremely slow and low at the current point. So this is the motivation actually for Artemis, which is an automatic and real-time detection mitigation system. We have Artemis offers three key features. First, monitoring on the control plane based on multiple vantage points. The detection happens in near real time and with zero false positives based on ground truth supplied by the operator of the AS. And finally, the mitigation is automatic. It can take place over an SDN controller that interacts with the BGP edge routers of the AS. To give a more detailed overview, Artemis is completely self-operated. So an AS deploys it on its own network, and it can use the system to detect and mitigate hijacks against its own prefixes. So it's not a third-party service. The detection is based on public control plane sources, but offer BGP updates and BGP RIB information. Some examples are app collectors from BGP Mon and Ripris, and looking glass servers offered via Periscope. It's important to note here that, for example, Keita with BGP Stream, they plan to offer real-time access to many more monitors than today. So Artemis can take advantage of these current developments and have a more complete view of the AS-level internet. At the current state, the mitigation we propose uses prefix deaggregation. So the idea here is that the affected monitored AS immediately announces sub-prefixes of the hijack prefix. And because in BGP, the most specific prefix always wins, the concept is that the whole internet will resume sending traffic to the correct AS. As you notice here, of course, this works until a net mask of /24, because after this, so for more specifics, prefixes are usually filtered by ASPs. So until /20 actually 3 hijacks, we can break the prefix and save the yes. But for /24 hijacks, where we cannot deaggregate, we need to find another way.
To be more specific, we can deaggregate, but most BGP routers will filter this announcement and don't consider it. So this would not work as it's supposed to do.
Exactly. So here comes some future work, some extensions we want to do with Artemis.
In order to combat this issue.
Exactly. So first of all is what we say MOAS mitigation. The idea is quite simple. We have the legitimate announcer and also one or more collaborator ASs. So when the AS in question is under attack, it signals the collaborator saying, help me. And the collaborator starts announcing the prefix from his own AS. It attracts the traffic and then relays it back to the original legitimate AS using data plane tunneling. So here we see some business opportunities like having an inter-ONOS signaling protocol exactly for such use cases, and also for what we call collaborative Artemis, which involves at least 2 Artemis applications talking with each other and collaborating to combat an ongoing hijack. The other front would like to invest on is using the dynamic configuration of multiple router types, but is currently under development by the Dynamic Config Brigade, as far as we know. And the idea here is to go beyond, for example, WAGA, and have arbitrary types of BGP speakers on our network with which we can interact, with which actually Artemis application and ONOS can interact. For example, to announce the more specific prefixes. Now, getting closer a bit to the demo setup, everything was implemented over an emulation platform called GNS3. So GNS3 is an open source mature project, and the community has noticed it's quite fast. It has a small footprint, easy to use, and most importantly, it's compatible with a multitude of implementations and visualization software, and also SDN switches, for example, OBS. So using GNS3, we also combine it with other tools like VirtualBox, which is a general purpose virtualizer for x86 or 64 hardware. We use Quagga, the Quagga routing software suite, especially the BGP4 implementation in Unix. We use ExaBGP. Now, ExaBGP is a Python library that allows us to interface between a BGP router and an application. And the idea here is that we can use ExaBGP to implement, for example, route collectors. So we talk to the router, we gather the updates, and we can then forward them, for example, to Artemis.
And in order to explain a little bit on this subject, since our own topology and our experiment and our demo happens within GNS3, we emulate a network internet monitor with ExaBGP in order to, since we don't have a connection to the outside world up to this moment, we emulate the monitoring tools through ExaBGP.
Yes, I will show you the exact setup in the next slide. And finally, we also use OVS, which is production quality multi-layer virtual switch, as the data plane of the ONOS network. So the demo topology looks like this. On the, yes, can I use the mouse? Yes. On the east side, we have the ONOS controlled AS or domain. Here you see the ONOS server that communicates with the BGP speaker. This is the OVS data plane. And here we have a test host that belongs to the network. On the south-west side, we have the hijacking AS, which consists of a router and a malicious server, but will, as you see later, intercept the traffic. And in between, we have two intermediate ASs, 65002 and 65001. It's interesting here to see that for 65001, this AS, we have implemented an ExaBGP-based route collector. This collector interfaces with the router of this AS. It collects the BGP updates, and it forwards them to ONOS, or more specifically to the Artemis application running over ONOS. Now here you will notice a link. So we just implemented this in the demo because we wanted an out-of-bound connection between the collector and ONOS. In the demo, it's an actual link, but in real life, what can happen over an out-of-band channel over the internet? The only limitation is that so this IP here, which we use to communicate with the collectors, should not be hijacked. So in real life, that's an out-of-band control channel, essentially.
And also a prefix that should not be advertised in BGP, so yes, nobody knows it. Because if it's hijacked, we will never hear of the updates.
So before giving the floor to Dimitris for the actual demo, do you have any questions on the concept of Artemis or other questions?
I do not, but perhaps if others do.
So once the ExaBGP collector tells the Artemis application, it's telling it that the prefix has been hijacked. What is the Artemis application doing? Is it
actually, the route collector doesn't say that we have a hijack. It simply monitors the control plane. Okay. So it's ONOS' job, actually Artemis' job, to find out that there is an ongoing hijack based on the monitoring information and decide to react to this hijack.
The reaction, this is Jono, if I understand.
Yeah, that is, yeah.
Hi, Jono. Hi. So what Artemis does is connects to the BGP speaker that belongs to the protected AS. So we're talking about this BGP speaker, this one, yeah, connects to it, and through CLI, through Telnet, deaggregates the prefix of this AES. So the prefix is 4000/8. It creates two subprefixes of 4000/9. So that creates a more specific prefix and it mitigates the attack. You will see exactly how it works in the actual demo.
Yeah, okay, got it. Is it doing anything on the data plane as well, or just telling the BGP speaker to deaggregate the prefix?
No, just that.
Yeah, just that. But we use the actual ONOS implementation for data plane. We don't change it.
Okay.
This from the side.
So should we proceed to the demo?
Sounds good. Yep.
Okay. Okay, so I'm Dimitris Mavromatis, and this is the demo of Artemis over ONOS. So we start here the GNS3 demo, and as we can see here, we have two virtual machines. The one on the left is the ONOS instance, and the one on the right is the ExaBGP route collector. So at first, we start the ExaBGP route collector by running our configuration. When started, it waits to receive a subscribe request for BGP update messages from the ONOS instance. So then we proceed to run ONOS. So when ONOS is started, we load our configuration file for Artemis application, and then we connect to the ONOS CLI. When we are connected in the ONOS CLI, we activate reactive routing and also the Artemis application. So as you can see on the right, at the ExaBGP route collector, the ExaBGP route collector received some packages. That means that the ONOS have subscribed the ExaBGP route collector and now receives the BGP update messages for its prefix. Also, if we see the logs of ONOS, we can see that Artemis has started, and also there is one ExaBGP monitor running right now on this prefix on this remote IP. If we open now the configuration file, we will see the settings of Artemis. So right here, this is the prefix that we are monitoring, and this is the specified AES path that we set as legitimate. So this is the origin AES, and these are the neighbors. Also, we have a threshold, which means that this is the frequency of Artemis that checks if there is a hijack or not. And below that, we have the monitors, which right now are route collectors or ExaBGP route collectors, and we can extend them to have a BGP mon or BGP stream or other looking glass servers that we want to implement.
Can I ask you where does the AES path information come from?
This one here. So this is the AES path. We set it. This is the origin AES. This is the first neighbor. This is the second neighbor that we say that this path is legit. So we receive a BGP update that doesn't correspond to this path. Then there is a BGP hijack.
Yeah. But
to expand a little bit on the question, this is how the topology right now is in GNS3 that we created. One thought that we have for the future, maybe if we can apply it in the future, is have Artemis detect the AES path topology of the AES that it protects and suggests an AES path to the actual network operator who operates Artemis. And the operator could edit this specific file and make any adjustments, but this can be also automated somehow, maybe through trace routes. We have different ideas on that, But for the moment, this is something that you create manually before you start Artemis.
Yes, also it's important to notice that in any case, what we have as ground truth from the operator is the ASNs from which he announces the prefix. It can be multiple, for example, in MOAS, and also his first hop neighbors, because he knows information and we trust his information. For the second hop neighbors and more, we can use what Lefteris said as the automated approach to detect S-level links.
Yeah. Okay. And this is the path between the which ASs it's the path. There's the AS that you're monitoring, and then what's the destination AS?
Can we go back to the presentation?
This is the one the one that has the monitoring server in it.
Yeah, so as you can see here, this is the origin AS 65004, which is the first neighbor is 2 and the second neighbor is 1. So first neighbor is here and second neighbor is here.
Okay, yeah, cool.
Okay, should we continue?
Yeah.
So this is the ONOS view of the current BGP routes. So now we proceed to check the connectivity between the host inside the protected AS and the intermediate AS. So we run a ping command from BPCD3 to this host, and we can see that the connection is established. So after the ping, we are going to run a trace route from this host to this host to check the hops. So as we can see here, the first hop is at this interface, the second hop is at this interface, and the third hop is at the destination client. So now we're going to run a ping to this destination with TTL sets to 2 in order to see the second hop, which is this interface. So while the ping is running, we are going to connect to the hijacker AS and announce the prefix that we want to hijack. So right now the hijacker AS announces the prefix that she wants to hijack. And we will see here that the second hop is going to change. So as you can see here, the IP changes from 2.2 to 1.1, which means that the second hop now is at this interface, which means that the traffic is hijacked. Also, after a while, the Artemis application detects that there is a BGP hijack at this prefix with this origin AS, and automatically announce 2 sub-prefixes of /9 in order to mitigate the attack.
At this point, also it's important to mention that the detection and the monitoring happens solely on the control plane. So it's quite lightweight. We simply monitor the monitors. And we don't have any heavyweight approach to monitor the traffic of the data plane. So what's important just to know how we do this.
So after a while, after 60 seconds, ONOS mitigates the attack, and as we can see, the BGP converts successfully, and the traffic goes, instead of 1.1 interface, goes through the original interface. So the Artemis application successfully directed the flow normally to the protected AS.
Also to add here is that the time it takes for Artemis to mitigate the attack depends on the time of the BGP requires to converge. Since we announce the sub-prefixes, It's just a matter of BGP convergence when the attack is mitigated.
Yes, but the detection is actually quite fast because it requires at least one update to be malicious or fraudulent.
So this was the demo. If you have any questions, feel free to ask.
I don't have any questions. I think this is actually pretty interesting. Anybody else online or in the room?
Do you have any plans to integrate Artemis more with the data plane of the system?
Not for the moment. How do you think of that? I mean, what do you have in mind exactly?
I'm not sure. I'm just wondering, because that's where using ONOS is going to come in handy, right? Because it has control over the data plane.
So one idea is doing this for the MOAS plan, actually, where the collaborator AS establishes a data plane tunnel between its own AS and the protected AS and starts forwarding the traffic using ONOS commands on the switches. So that's one idea.
Yeah, right.
That's what we have so far, at least.
Yes. For the aggregation, we don't need any special support, but for MOAS, yeah, I think we will.
Yeah, cool. Sounds good.
I think that this is something we discussed during ONOS build, Jonathan.
Yeah.
So yeah, that's the approach we have up to now.
Vasily, I was wondering that maybe it would be interesting to say something brief from our experience from running these type of experiments in the real internet using the peering dashpad rather than simply on emulation.
Yes, of course. So we have also run experiments in using the peering testbed that allows us to use actual ASNs and actual prefixes. This didn't have to do with STM, so we implemented this to measure the concept of Artemis before switching to STM and ONOS. And what we observed is that it takes a few seconds to detect actually any type of hijack. And while the mitigation itself takes at most 1 to 2 minutes. So the concept itself is quite interesting regarding the speed and its efficiency. And our next step is also we were wondering how to do a real-world ONOS-based experiment, probably, with peering or something else. But the experiments on peering are quite encouraging at first.
And also this work was presented last year in SICOM as a demo. And also was presented by me during the science fair of ONOS Build 2016. And on this idea, the Artemis over ONOS project was developed.
This is great. I had a quick question about the second bullet on the slide that you have here for the future work. Leaving aside the dynamic configuration, I just want to focus more on what kind of configuration you envision doing on the different routers. Is there any other mitigation that you plan to do using the configuration of the routers, or is it? Go ahead.
Yeah, so we plan to do something actually very simple. We simply need to be able to announce a prefix. For the aggregation, we announce 2 more specifics. And for the MOAS, we announce the same prefix from the collaborator. So we don't need any, anything complex on the routers, yes, but we need to interface with them.
You just need to connect to the router and announce the prefix through BGP. That's the idea, at least, for the moment.
Yes.
I see. Okay. So yeah, in that case, I would actually suggest that you don't necessarily wait for the dynamic configuration and instead abstract this ability using the driver mechanism. And then you can then use whatever means are currently available to be able to interact with the routers. And and clearly using Yang models and netconf directly would certainly be one of those means. But I don't think you necessarily need to wait for the full scope of the dynamic configuration to be completed. You can still start using netconf and Yang.
That is great, and also since Dimitris will be with you guys in Menlo Park from Monday, I think you have ample time to discuss all that and find the best solution. We can also be collaborating with you on the project, of course, from here.
Also, another question: where does the code base for this currently live? You have this in your own repository, I presume.
Yes. Do you want to see any code right now and discuss about it a little bit? Is this in the scope of this presentation?
Well, we probably don't need to see it. I just wanted to know, at least at a high level, where the code currently resides, and I presume that this is all this is all open source under Apache too. Is that correct? Or
Yeah.
It's inside the private repository right now that we just code there.
And do you have then any plans to make it available as part of a public repository?
Yes, for sure. In the future,
Yes,
yes. Our plan is to make it available for ONOS. So that's the whole goal, and all that can be discussed while Dimitris is there, for you guys to also check the code and review it.
Great. Yeah, because this could be one of the great candidates for like an ONOS Artemis repository, because we are starting to disaggregate the code base to avoid a single monolithic repo, and to give more control over the individual projects' life cycles to the contributors and collaborators. And we already do have some multiple repositories, and this might be basically a good candidate for setting up one specifically for Artemis, and could have the ONOS brand on it. It could eventually be subsumed into the overall build and distribution. Just because it's in a separate repo wouldn't necessarily mean that it would not be possible to ship it as part of ONOS package. Because it seems like it's a nicely self-contained application.
Sounds great. And after we finish this project, we will think and we will discuss with you guys, future ideas and implementations we can do.
Yep, great. Is there any other questions from, let's say, our online audience?
So I have one question though about the inter-ONOS signaling. So is there something in place or envisioned having two ONOS instances controlling different domains, communicating with each other?
Normally this would fall in the realm of federation, right? But we could. I don't think that this strictly requires the federation capability. It's informal federation effectively. You could potentially set up the Artemis application to be able to collaborate loosely with another domain, just using the network configuration similarly, by extending network configuration which you already have, effectively to point the Artemis application from one instance to another to establish a trust. And whether you use REST API, whether you use gRPC or something else, it's entirely up to you. Definitely the goal is to eventually work up to a federation capability, kind of a formal federation capability. But I don't think that this strictly requires it. You could probably proceed ahead without it. eCord was effectively doing similar thing, right? Well, this is really great. Thank you guys for the demo and for the overview. And another, I missed the timeline. When are you going to be in Menlo Park?
I'm going to be there at Monday, this Monday.
Okay, great. Well, looking forward to meeting you in person then.
Yeah.
I hope you won't hijack the meetings, guys.
No promises.
We have Artemis in place.
All right. Well, if there is no other questions, either locally or from remote audiences, I wanted to thank you very much for spending the time to do the presentation and to give the demo. Would you be able to share the link to the YouTube video that you use for presentation?
For sure.
Maybe you can enter it into the meeting notes that Utah linked in a chat, and that way it will be sort of preserved for posterity, and people can view the demo on their own timeline. Great.
We just did. We uploaded yesterday, so it's pretty fresh.
All right, sounds good. Well, thank you very much then. I think we can probably close the meeting, and you guys enjoy your evening, and we'll see you next week.
Okay, thank you.
Thank you very much.
Thank you very much.
everybody.
Bye-bye.
Bye-bye.
Have a nice day. Bye.
You too.